Welcome everyone to First Principles Podcast. As always, this is Trees, and I'm joined by my good brother
Elliot. You know it. I'm here, ready to go.
You know it. You sound pretty excited, man.
Oh, I am excited. This is gonna be an interesting one.
All right, okay, it's gonna be a good episode. So today's episode, we will be discussing in more detail hydrogen. We'll be going into hydrogen as a form of energy, how it could be used for transportation, how it could be used for large-scale applications such as the electrical power grid, and just where it comes from, all that good stuff. And let's just, without further ado, dive deeper into the subject of hydrogen.
Yeah.
So H2, hydrogen gas. You might have heard that it's the most abundant substance in the universe. That's great, but how can we actually use it? How can we utilize it? Because that was the biggest issue with nitrogen for the longest time. Mm-hmm. Nitrogen, really abundant, didn't have many sources of it, then eventually figured out a process of getting it out of the atmosphere. So
into the soil.
Yeah. Freaking crazy. Think about that.
It's wild. It's incredible that we figured that out, and it has allowed us to be on this earth in the way that we're on this earth, because without the advent of agriculture into that scale with the fertilization that they achieved through utilizing nitrogen that's in the air and fixing it, we wouldn't be able to produce the crops on the scale that we do with the amount of land that we have. All that would not have existed. And one thing to note is that in dry air, about 79% of it is nitrogen. Mm-hmm. You think of it as oxygen, but only 21% around there is actual O2, stuff that we breathe and need.
It's crazy how technological innovations can allow for almost exponential returns. One small thing can change the game completely, and that's the push that's necessary for hydrogen to get it to that next level as well. Because same with steel production, nitrogen production, all these different industries that required innovations in order to improve either scaling, decrease cost, all those things that are necessary for large-scale production. It seems like the push hasn't necessarily been there for hydrogen to have that leap, have that capacity to take that next step of large-scale integration.
Because to flourish.
Yeah, exactly. Just because, to backtrack on hydrogen, the hydrogen mechanism, whether it's combustion or whether it's the using the electrolysis of creating hydrogen, these are things that have been used for hundreds of years now. Since the 19th century and the 1800s, these were processes that were known. So we're looking at almost 200 years where we're familiar with these mechanisms of utilizing hydrogen. But for some reason, for whatever the reason may be, people might argue, whether it's political, whether it's there hasn't been a push from industry, whatever it might be, it just hasn't grown to that large-scale application. So what is hydrogen? Hydrogen is H2, two hydrogen protons that are combined together. One of the advantages of hydrogen when it comes to the electrical use of hydrogen is that when you use hydrogen in an electrolytic process, you have your hydrogen, H2, it's split up into your hydrogen proton. You have your anode, usually some sort of platinum, whatever. It splits your hydrogen. It goes through a membrane. Your electrolytic membrane. Then you have your protons traveling through that. You have your electrons traveling at the other end. And then when you split your electrons, now you can make a current. So because a current, what it is, just electrons going through it. So by then combining oxygen, right, which we have abundantly from the air. We combine oxygen at the end of the anode to the cathode, right? So with our protons that started out at the anode, they get pushed to the cathode and combine with oxygen in order to generate H2O, good old water, as your byproduct. So in theory, it's considered to be a net neutral or net neutral in terms of the carbon emissions. There's no carbon emissions that are associated with your fossil fuel combustion, right? So in that sense, it does pose some advantages.
Yeah, I was just going to say, if anybody was confused by that process being explained, the process which takes place inside a fuel cell, you're not alone. It's a pretty crazy, fascinating process that's going on here. And what I want to say to that is that hydrogen, let's just talk about what that hydrogen is. Just the gas, the H2.
Mm-hmm.
Okay. That is its own thing. That comes in. All right. And then what do you, and that can be stored in its own container and shipped as just a gas. But when you actually want to produce electricity from hydrogen, you need the fuel cell, which then the hydrogen gets inputted into it, and that whole process that was just explained occurs. And let me just recap. So it was hydrogen comes in, oxygen comes in, and you need some sort of catalyst that's usually platinum. And out, at the end, you got water exiting, and you got electricity flowing, basically, right?
Mm-hmm. Exactly. And it's such a simple process when you think about it. And this is what has been known. The fuel cell process has been known for hundreds of years, but for whatever reason, it hasn't been fully developed into a system that is within large scale application. Now, there are certain companies that are trying to do that, and we'll go into that. But some of the challenges that have been focused around the very nature of accepting hydrogen is because we've all maybe seen and heard the image of that flying air balloon that was
the Zeppelin.
What was it called? Do you remember? It was like
No,
it was like the German one. You know, it was like one of the biggest ones, kind of like the equivalent of like the Titanic, but for the dirigible. I always like that word. Instead of the hot air balloon, it's a dirigible. I don't know. And it caught fire. Many people died. So whenever people think of like hydrogen for hydrogen power, they always have that image, and then they're like, "Oh no, it's not safe." But then when you think about it, like regular gasoline combustion, we have to take safety precautions. We have to take certain measures in order to make sure that they're safe, and whether it's not smoking at your gasoline station or the method in which the actual fuel is transported and stored, that there's safety measures that are taken into account. For example, the tanks and stuff, and there's safety measures that have to be taken regardless. So it's difficult to get over that psychology that people have in their minds about the safety of it. But I think that it is one that can be overcome just because we do it on a daily basis. There's cars that are running on natural gas. There's cars that are running on diesel. We have, and one of the benefits of hydrogen is that because it's so light, if there is a leak, instead of pooling up like certain fuels would, what happens is that it just vaporizes into the air since it's lighter than air. So there are some certain safety benefits that hydrogen does pose.
Yeah. And we're going to get into it, but I want to say I agree. There are safety concerns, and some of them are unique to hydrogen and are different than other fuels that we use. But I agree that we can overcome them. And I want to add this to everybody. I want everybody to think about this, I should say, is that this whole thing kind of reminded me of the whole Thomas Edison, Nikola Tesla battle over the currents, okay? In that story, in that, you had Tesla doing the AC alternating current, and you had Edison pushing direct current DC, right? And Edison pulls this stunt at one point, or this is how the story goes, where there's some New York murderer basically that is being sentenced to death by electric chair, and he convinces them to use AC power and the electric chair to basically show how dangerous it is, and in an attempt to smear Nikola Tesla because he was competing with him, right? But fast forward to today, and all our houses have alternating current, okay? Yeah. But the point there is the use of a competitor saying, hey, this is more dangerous, therefore you shouldn't use it, is like the oldest
trick in the book.
Yeah. It is. Well, so when we talk about why certain technologies haven't taken off, and there's documentaries on who killed the electric car, and we can talk about the iron grip that the oil and gas industry has on the world now. These are all players, and I wouldn't say any one of them has completely been the cause of it, and I can only speculate in some regards to this, like what really has stopped this. But I wanted to point out it was Elon in our last episode, or it was our episode on carbon tax, where he talks about if the fundamental good of Tesla is that if we can do one thing, it's that we increase the rate at which sustainable energy the utilization of sustainable energy it comes to our future. So keep that in mind. The reality is some technologies have been used longer and worked on longer, and therefore are going to present as being better because of all the time and energy we've spent on them, making them that way. So some of these new technologies are just in their, not necessarily in their infancy, but they're in their adolescence. And so you're still going to have them act up and cause problems, and people are going to, every time a problem's going to come around, every time, this is maybe a bad example, but every time a self-driving car, crashes or kills somebody, you're going to have people saying, well, that's the reason why we don't proceed any further on this. And somebody else saying, well, they're going to argue about it. But every time something goes wrong, it's going to be a check mark for where, somebody just decide if they want to proceed with this, but with the technology. Now, I think that you have to not disregard the times it goes wrong. I don't like that. Like, you have to look at a track record of something and go, okay, some technologies or some things that we make, if there's enough things that go wrong with it, you might have to scrap it and go back to the drawing board. Okay, I'm not saying just keep pushing forward, even though it causes
thousands of people are dying.
Yeah.
Screw it, keep going,
keep going.
Stay the course.
Stay the course. Just stay on target. We're still getting profit. Fuck it. Yeah. But that's not the point. I'm just saying that any new technology is going to have hiccups, and just one or two or three hiccups aren't necessarily a reason to throw the baby out with the bathwater.
Yeah, and it's kind of like what you said. It's going to be accentuated by the players of the game that have something to lose with that new technology becoming more developed. If you have all your chips invested in a competing technology, then yeah, you're going to go out of your way and point out all the flaws, all the things that are wrong with that particular new technology, which kind of like you touched on with who killed the electric car, maybe with some oil and gas players that had some influence. Not to say that that's exactly what took place, but you have to look at the demand, the supply, all these things. But it is to say that hydrogen definitely has its naysayers, and funny enough, one of them is Elon Musk, which I find really interesting because considering the fact that he tried to build Tesla, which is an electric car company, he would have had so much opposition towards that premise. Oh, why would you build an electric car? It's dumb. It's more expensive than gasoline power vehicles, this and that. And when you hear him talk about the hydrogen vehicle, it's kind of interesting because he almost has that exact same mentality and those same remarks towards hydrogen fuel cell vehicles, which he would have received towards his electric vehicles from gasoline powered vehicles. So it just seems kind of really ironic and hypocritical when I hear him just bash on hydrogen powered vehicles, just because, like, dude, weren't you in those same shoes like just a few years back? Like, how quickly you must forget. I don't know, it's kind of funny to me.
Yeah. Now I have the clip because I want to let's hear it from the horse's mouth, but I want to point out that this clip was from Elon in 2015, so it's 6 years old. Maybe his views have changed. I don't think they have that much, but because I've seen him tweet more recently about this. But keep that in mind. It's 15 years old, and here's his thoughts on hydrogen.
Okay, let's jump into clip number 1.
I don't want to turn this into a debate on hydrogen fuel cells because I just think that they're extremely silly. And the people have published, there's multiple sort of rebuttals of it online. It's just very difficult to make hydrogen and store it and use it in a car. Hydrogen is an energy storage mechanism. It's not a source of energy. So you have to get that hydrogen from somewhere. If you get that hydrogen from water, so you're splitting H2O, the electrolysis is extremely inefficient as an energy process. If you say took a solar panel and used the energy from that solar panel to just charge a battery pack directly, compared to try to split water, take the hydrogen, dump the oxygen, compress the hydrogen to an extremely high pressure or liquefy it, and then put it in a car and run a fuel cell, it is about half the efficiency. It's terrible. So why would you do that? It makes no sense. And then hydrogen has very low density. It's a pernicious molecule, likes to get all over the place. You get metal embrittlement from hydrogen. If you get a hydrogen leak, it's an invisible gas. You can't even tell that it's leaking. But then it's extremely flammable when it does and has an invisible flame. If you're going to pick an energy storage mechanism, hydrogen is an incredibly dumb one to pick. You should just pick methane. That's much, much easier, or propane. Hydrogen fuel cell, the best case hydrogen fuel cell doesn't win against the current case batteries. So then obviously it doesn't make sense. That will become apparent in the next few years. There's no reason for us to have this debate. I've said, my piece on this. It will be super obvious as time goes by.
Super obvious when time goes by. I imagine he's going to be proven wrong based off the research I've done for this podcast, but I love how he starts that off with, I don't want to make this into a debate about hydrogen, and then proceeds to
make it a debate.
Give his whole 2 cents on it, and just those are fighting words, man. It's like, okay, let's talk about it. And what I've done here, just so you know, I've kind of gone through what he said there verbatim and kind of broken it down. So before I get into that, was there anything that jumped out at you from what you heard there?
Yeah, I mean, one thing that he talks about is the storage of hydrogen and the conversion, from your electrical grid, and from a different power source, from a primary power source into hydrogen as a secondary power source. And I think that's an important thing to touch on, that hydrogen is a secondary form of energy. It's not a primary form of energy. So where you have your natural gas, you have your fossil fuels, you have your solar, whatever, that's your primary form of energy. And then that is used to then convert into hydrogen, which is a form of energy storage. Similarly, though, that's fundamentally what electricity is as well. So when we look at electricity is also a secondary form of energy because we don't have a primary means of electricity. It's just a secondary form that's generated after we have our initial form of energy that's created.
Yeah, I assume like if you were capturing lightning, that would be one way of almost considering it primary. But yeah, so hydrogen is an energy carrier. You can't just dig into the ground and find a pocket of hydrogen like you can find a pocket of natural gas, which is just mostly methane. So, but even fuels that are primary, such as methane or natural gas and petroleum, they have to be refined. But the refining usually involves removing impurities. It's not manipulating the chemical bonds in such a way that you're creating something completely new. It's more about like cleaning it up. That's what's so great about hydrogen, I think, in many ways, is it has so many applications because you're storing energy in a physical thing, a gas, and if you get that gas under enough pressure and you cool it down enough, it can become a liquid, which we'll get into a little bit. But yeah, it's the secondary form of energy. It's an energy carrier, and this is a concept that it's good to explain because that'd be something. It's kind of you hear people say energy carrier, but what the hell does that mean?
And the next thing is that, obviously he's going to point out all the flaws of hydrogen and none of the flaws of electric, which isn't the goal of this episode necessarily, to talk about the flaws of electric powered vehicles, which I personally am a fan of. But it does have, when you do compare the vehicles of a hydrogen nature, which is based on the fuel cell, versus an electric powered vehicle that's just straight electric, there are some changes. There are some disadvantages and advantages on both sides. If you look at purely efficiency, okay, that's one thing, but then there's other convenience factors, such as the time that's necessary for refueling. Similar to your gasoline-powered vehicle, your hydrogen-powered vehicle, you can refuel within a minute. You don't have to spend 20, 30 minutes just chilling at a refueling station, which allows for long-distance hauling, right? So again, we have to, whenever somebody says, that's dumb, that doesn't make sense, it's like you have to look at within what context or within what assumptions that you're looking at. And I don't think that Elon Musk is being very honest when he portrays the conversation in that light. And obviously it's his prerogative. He's trying to sell you his Tesla's electric vehicles. That's great, but it also doesn't consider, for example, the distance that is required or that the vehicle is capable of traveling. So hydrogen powered vehicles, that fuel cell vehicles, have been shown to have much longer distances that they're able to go before requiring refueling. So that's another benefit in the hydrogen category. So, but again, I don't want it to be like fully like, okay, which one's better, which one's not. That's not the goal of this podcast. It's more just to get an idea of where hydrogen can be used. Maybe we can do like another episode later on where we go fully in depth on the breakdown. But I just wanted to kind of point out that there are benefits that hydrogen powered vehicle does have over the just purely electric vehicle.
Oh, and I have some clips about it, so we will get into a little bit today for sure.
We'll talk about it. Okay.
I wonder, it just came to mind, but Elon Musk, he's an engineer, he's a businessman, he's out there running a bunch of different companies, and he gets it through his head as he's trying to develop an electric car company to call hydrogen silly and dumb. And using those words is unwise, I would say, because when you call something dumb, like it's pretty harsh. Like it's a technology like hydrogen has its problems, but in no shape or form is it dumb or silly. Yeah. But you say that and you get a laugh from somebody, and then as an the crowd, sees him as a genius. Oh my goodness, Elon's saying it's dumb. And they go, oh, he must really believe it's dumb, and that's why he's not investing in it. And I go, but why isn't he investing in it? Because he's investing in all these different ventures, right? It's not like he's strictly electrical, maybe he almost handcuffed himself to be outside the industry of hydrogen by being so critical of it up front in his attempt to push his electric. I don't know, I'm just speculating here, but do you think like him using words like silly and dumb and fool cells and mind-bogglingly stupid, like those type of words are overly harsh from somebody who's an engineer who knows like people are actually investing in doing crazy stuff with hydrogen. So I almost feel like he almost handcuffs himself. What do you think of that?
Yeah, like his own ego is preventing him from seeing the benefits that it does hold. That could be it, because he's almost taken such a harsh stance that if he were to turn around on it, then I'm sure there'd be like a host of internet trolls that would then come
roast him, be like, "Oh, you're such a hypocrite! You said it was stupid." Yeah.
But yeah, I do think that it's kind of like irresponsible for him to say that kind of stuff, because if your whole goal is to get the planet on towards sustainable energy, then and sustainable and renewable energy sources, then hydrogen should naturally be a part of that. And there's plenty of literature from plenty of smart people that does look at that possibility. And I just think that's kind of foolish for him to go down that route, because again, when he was earlier on in his career with Tesla, he would have probably received much the same criticism of people saying, oh, that's fool's errands, that's silly, why go down that route? So it just boggles my mind that he can be that against it, considering how he probably faced the exact same stuff. So
yeah,
it's just silly. You want to jump into the next clip?
No, not yet. I want to kind of break down a bunch of stuff he said there. So let's so let me read it verbatim. So hydrogen fuel cells are extremely silly. Hydrogen is an energy storage mechanism. It's not a source of energy, so you have to get that hydrogen from somewhere. Okay, so you have to get that hydrogen from somewhere, and basically there's two ways of doing this, two categories. One is where you use electricity to power electrolysis to split water and generate hydrogen gas, and this is the form that's considered green. This is the way of making hydrogen that doesn't involve using petroleum hydrocarbons or methane, but it actually only makes up less than 5% of the way most people right now are making hydrogen. The other way people are making hydrogen is through reforming. Now, this is interesting, because when we talk about how do you make hydrogen, you're talking about upstream. Are we still involving hydrocarbons? And we are, to a large extent. So about 95% of hydrogen produced in the United States is made from natural gas reforming in large central plants. So 95%. Okay. Now, this isn't a complete loss, and we'll talk about why even if you start to make hydrogen using natural gas reforming, there are net benefits to using hydrogen and putting into cars. But the idea of making green hydrogen, in the sense you're just using electricity from renewable sources like wind and solar to power electrolysis to split the water, that so far only makes up a very small amount of the way hydrogen is made and is harder to achieve. So that's just one I want to put out right there.
Just to add to that, both of those are very well understood technologies, though, and I think that's actually one thing that he said that I also want to touch on, that where he said it's a really inefficient process, the electrolysis, so splitting your water, or he said that it was an inefficient process, right? The whole electrolysis process, and converting electricity into hydrogen for storage.
And I found a source that said that electrolysis is 70% efficient. So you have 30% of the energy you put into electrolysis gets lost.
Yeah,
but that's still pretty good.
I mean, I've even heard like 20% loss too. So 70 to 80% efficiency, which is not bad. Like it's not the best, but it's not the worst either. So from that point of view, I think that again he's trying to cast it in a negative light, or in a more negative light than it actually is.
Yeah.
Because when you look at natural gas power plants, like they're operating at like 60% efficiency, something like that.
I couldn't tell you.
But I mean, it's just to say that nothing is operating at 100% efficiency. So if you're at 70 to 80% for that conversion, then that's not bad at all. And we do have technology. These are well understood technologies, the electrolysis process. Yeah. And when we have hydrogen that is used for in the fuel cell, we have to consider how it's generated. And I think that's a really important thing that you just brought up, is that you can generate hydrogen in different ways, whether it's via using electricity or with methane reformation. I think that's where the whole green hydrogen comes in.
Yeah.
Into question. And when we have green hydrogen, so what does that actually mean? It means that your whole process comes from like carbon neutral sources. So if you have your surplus electricity or surplus energy that's coming from solar, surplus energy that's coming from wind, the benefit of hydrogen storage on a large scale grid really comes in when you are using those renewable technologies and you have surplus generation at times when the demand isn't there. So that's where hydrogen storage can really be beneficial, because when you're generating energy, so you have a lot of supply, but the demand isn't there from people actually using it, then that energy goes to waste, that electricity goes to waste. So the whole idea behind hydrogen storage is that, hey, why don't we actually store this in some sort of media? Again, that's where the whole idea of a secondary energy source or secondary energy medium comes in, where it can be used and stored for longer durations, which it can be more so than an electric battery. So
yeah, and I mean, you're talking about electricity going to waste. Might as well get 70% of that back and stored as hydrogen than have it go to waste. And waste is interesting because there are ways to transport it to other locations, but there's all the infrastructure and logistics with that, and there's obviously infrastructure and logistical issues with making hydrogen too. But I just think it really, when combined with anything that's generating surplus energy, whether it's a hydroelectric dam, which is a big one here in Canada, could open the door for just a great way to keep the possibilities of what you could do with that excess energy open to a broader spectrum, like of uses, if you do it as hydrogen instead of just selling it down the lines to a neighboring province or
maybe
even
just grounding it. You just like waste it. So it's like what's dumber, just wasting a bunch of energy that you've already generated, or storing it in a proven method that has been shown to work, and then using it at a later date when you actually do need that supply that you've stored. Because we're not doing it with batteries, Elon. Sorry. Maybe, I don't know, he was talking about more for application for vehicles, and this is different from large scale storage of it that would be applicable to the grid. But it just kind of shows that you have to look at the big picture, where if you're already generating this energy and it's going to waste, then why not store it? What would be the downfall of that? Like, how is that dumb? How's that mind-boggling? Is it dumber to just waste it and just do nothing with it? Like, I think so.
Yeah. Okay, I wanted to read this. So this was hydrogen production through natural gas reforming. And this is from the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy. So remember before I said 95% of hydrogen is in the U.S. currently is being made through natural gas reforming. And they're saying, this is what they wrote. They say, why is this pathway being considered? Okay, reforming low-cost natural gas can provide hydrogen today for fuel cell electric vehicles, FCEVs, as well as other applications. Over the long term, DOE, Department of Energy, expects that hydrogen production from natural gas will be augmented with the production from renewable nuclear and coal with carbon capture and storage and other low-carbon domestic energy resources. So they're saying hydrogen production, they believe in the future, will be augmented, so driven forward or helped by increases in renewable energy, increases in nuclear, and increases in coal, all of these things, coal with carbon capture. Okay. They go on to say petroleum use and emissions are lower than the gasoline-powered internal combustion engine vehicles. The only product from a FCEV tailpipe is water vapor. But even with the upstream process of producing hydrogen from natural gas, as well as delivering and storing it for use in the FCEVs, the total greenhouse gas emissions are cut in half, and petroleum is reduced over 90% compared to today's gasoline vehicles. So that last sentence, I think, is key. So even if you were to continue to use natural gas to make your hydrogen, and you weren't going to go, use electrolysis, then you still substantially 90% reduction in petroleum use by doing this. Granted, this is, assuming that all cars have been retrofitted to take on hydrogen, but the idea that you'll hear critics say, well, you're just hiding where the actual emissions are, and you are changing it to the same way. It's the same thing with the electric cars, and we've talked about this even before. There's still the mining and there's still the use of hydrocarbons downstream, but it's in this case here with hydrogen, and the same with EVs, is you've changed the amount of emissions, whether it's emissions that you're concerned about for air pollution or emissions you're concerned about for climate change. You've reduced those from happening in your cities with these vehicles, and overall it's been reduced in other ways by still using fossil fuels, right? We haven't just completely abandoned them and got rid of them. They're instrumental in kind of like a stepwise approach to ushering in these new technologies. Does that make sense?
Yeah, I mean, they all have to. It's a sequential process, and it's a bunch of things that have to be done together. Like hydrogen isn't a silver bullet. It's not the end all be all, but how it's used in complementary of these other technologies that are becoming more widely used and accepted within the electrical grid, then you start to see where hydrogen fits into the picture. I think that's where the conversation needs to be of how is it going to fit in with this new energy landscape where we do have more renewables, we do have nuclear, we do have hydroelectric, and then what do we value? Do we value having clean cities that don't smell like trash? Because or don't smell like combustion, exhaust, because that is, I think, to me, a huge benefit. Because like I was just recently in Vancouver, and one thing that I noticed there is that their city
smelled like poop.
It didn't smell like it smelled actually kind of nice.
Okay.
Like where the places where I was at, they're using electric buses, right? So you're reducing your emissions from your buses by having them electrically powered. And whereas in other cities, they might be diesel powered, and you don't want to be smelling diesel too much because that stuff is not too nice to smell.
Where were you that you noted that the diesel use was pretty high. You were in
just Ottawa.
Ottawa.
We got diesel buses.
Yeah.
Like most buses are diesel. Or for example, where I was at, where if you want to know the biggest example of this, okay, let me tell you where the biggest example where I saw of how valuable clean air from your exhaust is. That was, and I might have mentioned this before, was in Nepal. When I went to Nepal, people over there were using face masks to help them with breathing as a result of all the exhaust that was coming out of the tailpipes of their motorcycles, of their cars, and it's several factors that lead to that. It's the low quality of the technology, so you have low quality combustion happening. Then you have the valley of Kathmandu, which is kind of like a valley type of geographic location, so it's kind of like a sink for gases to stay, and then it's also in such a way where there's a lot of sun that hits the area, and then it generates smog, further forcing the gases to stay in the area. Then you have really small, narrow streets, really tall buildings, so you're almost suffocated with this gas. But literally everywhere you go, again, it's the most extreme example to show what the value of having clean tailpipe emissions is that when I came back to Canada, I was like, oh damn, I'm so like, take a nice breath. Yeah, like legit, it's night and day, man. Like, so what do we value? Do we value like clean streets? Do we value being able to go into a city and not having it smell like just real crap, because it all stays in there and it all mixes with the pee, with the poo. You already that's already bad enough, but then you throw in like all the tailpipe emissions.
Yeah,
you can imagine, like, a city like Toronto doesn't smell the nicest.
Not every city's got a stink to it, and it's not just all tailpipe. But I think you made an interesting point there, which is the geographic location combined with the geography, the elevation of the land, changes the way weather occurs in and around a city. And some cities that are in a spot that makes them more windy can kind of get away with it. But other places that are perhaps in like a valley, or even Vancouver is interesting because their weather is so dictated by the ocean and the mountains and all that. Depending on how things go, you could have a lot of air sticking around for a bit in certain locations, which just amplifies the issue, right? I'm going to just continue on with Elon here. So he says, so if you took a solar panel to charge a battery pack directly compared to try to splitting... Let me start again. So if you took a solar panel to charge a battery pack directly compared to try splitting water, I just wrote it wrong. That's why. Take the hydrogen, dump the oxygen, compress the hydrogen to extremely high pressure to liquefy it, then put it in a car to run a fuel cell. It's about half the efficiency. It's terrible. Why would you do that? It makes no sense. Okay, so he's talking about the whole process here, but one of these processes I want to talk about: compress hydrogen to an extremely high pressure to liquefy it. Now, this is not something that's unique to hydrogen, but it's something that you have to deal with all types of gas fuels, such as propane and methane. But there's a catch with hydrogen. Hydrogen is harder to work with. So propane, everybody knows. Most people know what propane is. They get it for their barbecue, right? Inside that canister is liquid propane, and it's under pressure, but it's at normal atmospheric outside normal temperature, atmospheric pressure. Inside, it's at pressure, and as soon as you open it up, that liquid turns to a vapor as the pressure changes, as it comes to atmospheric pressure. Okay, propane is very easy to change to a liquid. Just by increasing its pressure. And you do that because gases are less dense. You can fit less of them into a container. So when we're talking about economically transporting a fuel, you want to put it as densely, make the space that it occupies as small as possible. So propane works very nicely for that. When you deal with something like natural gas, okay, it takes not just pressure, but a decrease in temperature to liquefy it. So a lot of places, a lot of cities are connected to gas lines, and that is, that's a vapor form. That's a gas form of natural gas coming through the pipe. But when they put that on a ship to transport it, they often change it to a liquid form, and that requires that they basically drop the temperature of it. And I have it here somewhere, and they increase the pressure. Let me see here. So to keep methane liquid at room temperature. Okay, here's an example. So let's say you don't decrease the temperature. To keep methane as a liquid at room temperature requires a tank that maintains a pressure of 32,000 kPa. That's 4,600 psi. Okay, that is pretty high considering what your pressure in your car tires is around 40 psi. So we're talking 4,600 psi to compress natural gas. And in comparison, your propane cylinder only requires 123 psi to change that to a liquid. So basically 3 times the amount of pressure you put into your tires is what it takes to change a propane from a gas to a liquid. But hydrogen requires even at 5,000 to 10,000 psi at normal pressures, hydrogen remains as a gas. You need to basically start to cool it down, much like you do with methane, and you need to start cooling it down quite cold, like you were talking negative 200 and 50 degrees C. Okay, methane, it needs to be done pretty close to that as well. But here's the reality is that methane is just has a higher density. Methane's density is 0.7 kilograms per meter cubed, whereas hydrogen's density is 0.09 kilograms per meter cubed. So hydrogen might be a great fuel, but to package it and move it, it takes more work to get it into a more compact form, basically. So it's 8 times less dense than methane. So there's a logistical problem here with methane that cannot be ignored.
Yeah, and I just looked up that number real quick for liquid natural gas. It's minus 160 Celsius that is cooled at.
Okay, minus 160 for natural gas. Mm-hmm. Okay, versus minus 252 for hydrogen. So it's a little bit more. Here's an interesting bit of information. So a volume of around 11 meters cubed, which is the volume of the trunk of a large utility or commercial vehicle, is needed to store just 1 kilogram of hydrogen, which is the quantity needed to drive 1,000 kilometers. So if you don't compress hydrogen, you need basically the back of a tractor trailer, okay, filled with hydrogen just to drive that car. Not just to drive, it's still very impressive, but to drive the car 100 kilometers. So that's going down the highway.
100 or 1,000 kilometers?
100 kilometers,
okay.
Sorry. So about an hour of driving down the highway. But you can start to condense it, and it goes on to say, if you compress it, they can. What do they say here? So at 700 bars, which is 700 times normal atmospheric pressure, hydrogen has a density of 42 kilograms per meter cube compared to 0.09 kilograms under normal pressure and temperature. At this pressure, 5 kilograms of hydrogen can be stored in a 125 liter tank. Which it goes on to say, this technology enables us to store enough hydrogen to allow a car that runs on fuel cell battery to cover between 500 and 600 kilometers between fill-ups. So it's essential that you compress hydrogen to make it usable for vehicles. In some places, it's not as important. But
and we do have those cars. We do have those examples, like Toyota. They have the Mirai 2 that functions based off of that whole principle. They don't have a liquid fuel. They don't have liquid gas. They don't have liquid hydrogen, I should say, that's within the vehicle, but rather it's a compressed tank, and you don't necessarily have to liquefy it. So again, going back to what Elon Musk was saying, oh, you have to liquefy it. Well, who says you have to liquefy it? You know what I mean? Like that, like if it depends on the application. Depends on the application.
Depends on the application.
Maybe you do, maybe you don't.
Yeah.
You know what I'm saying? Where if you are able to get away with cars that are using hydrogen at a pressurized as a pressurized gas, again, those cars are running currently in operation. They're being produced by Toyota, and they are not liquid hydrogen, and they're able to get that level of performance. And just to touch actually on the storage side of things, I wanted to bring up this article that I found, which looked at a different method that was developed for storage that actually tries to address this whole issue and how it is an improvement in the efficiency of hydrogen storage. So the title of the article is Hydro-Quebec, which is the producer of electricity in Quebec, which is a province within Canada, is to work on bringing to the commercialization stage hydrogen storage technology developed by the University of South Wales. So this is a joint partnership between Hydro-Quebec and University of South Wales, and basically what it talks about is that they developed a new storage mechanism that helps with the storage of hydrogen. And just to go into it real quick, the two organizations have signed commercial agreements to transfer the patented hydrogen storage technology arising from University of South Wales to Hydro-Quebec to enable its commercialization as part of an ongoing efforts to decarbonize industry. So some of the benefits of it are that there's greater storage capacity, less weight for the same storage capacity, increased safety linked to the lower tank pressures. So you avoid needing to have as much pressure. And I'm just trying to get the actual numbers that they gave. But
okay, while you're looking for that, let me jump in here.
Yeah.
So Elon continues. He says, then hydrogen has a very low density. It's a pernicious molecule that likes to get all over the place. You get metal embrittlement from hydrogen. If you get hydrogen leaks, it's an invisible gas, so you can't even tell it's leaking. It's extremely flammable. It has an invisible flame. If you're going to pick an energy storage mechanism, hydrogen is an incredibly dumb one to pick. You should just pick methane. That's much, much easier. Or propane. So I'm going to break down quickly some of these criticisms. So he says it's pernicious. Okay. So pernicious, dictionary definition of it, it has a harmful effect, especially in a gradual or subtle way. I love this definition that what was the dictionary I got this from? It was the Oxford Language Dictionary. You know how they give an example of the word used in a sentence after they give the definition? So this is their example. The pernicious influence of mass media.
Yeah.
Yeah, I like that. So, okay, it gets everywhere. Most gases get everywhere. So let's jump into some other things. Metal embrittlement. This is a real thing that hydrogen is unique to hydrogen. It storing it in certain metals, it basically weakens them and makes them more likely to crack or break under stress that it already existed in the metal from when it was produced or from external stresses that happen. But there are multiple ways around hydrogen embrittlement, which involves coating and uses of other types of materials to prevent embrittlement. So it's a barrier, but it's already been overcome, in my opinion. So the next one, he says, hydrogen leaks. It's an invisible gas, so you can't tell it's leaking. Well, guess what? Methane's a colorless, odorless gas. You can't tell. Propane is colorless. I believe it's odorless as well. Often gases that we use for fuel have a chemical added to them to make them have an odor, so we can notice that they're leaking. So it's just a common danger of fuel gases. So that nothing really new with it being an invisible gas. It's extremely flammable. This is actually justifiable, and I want to talk a little bit about a concept. So for gases, there's something called the lower explosive limit and the upper explosive limit. Okay, to have something burn, okay, or to combust, you need three things, right? You need air, you need the fuel, and you need an ignition source, okay? And the ratio of the fuel to oxygen has to be right for combustion to happen. And so when we talk about gases having explosive limit, we're talking about the proportions that when you add that fuel to oxygen, blended with oxygen, it will allow it to combust. So if you have not enough fuel mixed in with oxygen, it's called being too lean. So if you're too lean, you can put a flame into the mixture, but nothing will combust because there's not enough of that fuel in the mixture. And this is called being below your lower explosive limit. Once you're above your lower explosive limit, you put a match in there and you'll have the explosion happen. But then there becomes a point when you add too much fuel and there's not enough air. This is called the upper explosive limit, and this is when you've got your fuel rich. Okay, so with that in mind, let's look at three fuels. So we got methane, propane, and hydrogen. So methane has a lower explosive limit of 5% and an upper limit of 17%. Okay, so between 5% and 17% mixture, you're going to have an explosion. If propane has a 2.1% is its lower explosive limit, and its upper is 6.5 or 9.5, percent. So between 2 and around 9% mixture, you're going to have explosion. If it gets above 9, it's not going to blow up. If it gets above 17, it's not going to combust. Hydrogen, we got a much bigger window. So for hydrogen, your lower explosive limit is 4, which is pretty close to 5, which is methane, but your upper explosive limit is 75%, okay, compared to methane, which is only at 17%. So we're talking the chances that when hydrogen leaves a container and starts to mix with air, there's a larger window for it to create the conditions to allow explosion to happen. However, with that said, it loves to dissipate quickly, very quickly. So it is, I think it's valid to say, yeah, it's extremely flammable, more flammable than methane and propane, because the conditions to make it flammable exist in a wider range. But this is not a complete barrier, I don't think, in terms of its use. Again, it's an invisible flame, he says, and this is true. Both methane and propane, their flames are not invisible, okay? But this is what the U.S. Department of Energy said about the safety of hydrogen, okay? By their nature, all fuels have some degree of danger associated with them. The safe use of any fuel focuses on preventing situations where three combustion factors, ignition source, oxygen, and fuel, are present. With a thorough understanding of fuel properties, we can design fuel systems with appropriate engineering controls and establish guidelines to ensure the safe handling and use of fuel. So they just acknowledge up front all fuels have an inherent danger with them. You understand their properties, though, you can design around them. It then goes on to say, a number of hydrogen properties make it safer to handle and use than fuels commonly used today. Okay. For example, hydrogen is non-toxic. In addition, because hydrogen is much lighter than air, it dissipates rapidly when it is released, allowing for relatively rapid dispersal of the fuel in case of a leak. That's such an important thing for them to say, because they're already saying right there that of the fuels they use, hydrogen is it's safer than some of the ones that are used. So anybody arguing, oh, it's so dangerous, it is, but it's not more dangerous than anything we're currently dealing with. And the fact that it's non-toxic and disperses rapidly, that helps. That helps. So I don't know. Did you have those numbers you wanted to look at?
So they don't go into too many numbers specifically, but the premise behind the article was that it's a means of storage in an absorption media. So you have the hydrogen that's embedded is absorbed within a medium that allows for higher percentage of hydrogen to be stored in that medium, and then later can be extracted. And again, this is coupled with a large scale distribution network. So again, you have an electrical grid, the power grid. You're trying to manage the different loads, the different demands. And Quebec, they have a population of roughly, I think, 13 million or so, 8 to 13 million. Excuse me if I'm wrong on that. But again, it's a pretty large scale application, and it is being used for these industrial large scale power grids. So just to say that there is a lot of movement in hydrogen investment that isn't just purely for vehicles. So I think that's, again, which we've kind of pretty much been talking about throughout this podcast, is that, but just to say more clearly that you have hydrogen for many different applications. Most of it that's produced is used for different applications on site, actually, for refining or the refining of metals, for all types of different things that aren't even related to a hydrogen fuel cell vehicle or hydrogen powered vehicle. So that's important to point out, that there are many different uses of hydrogen.
Yeah, no, it's such a good point, and I think people get caught up on its use for propelling a vehicle, but that might have been where you've seen a lot of talk about it. But I will show you that energy producers are thinking that is actually the end goal, and in the interim, as we develop the technology, it's going to be used for direct fuel use, which we'll get into shortly. It's going to be used for energy storage, and it's going to be used for these industrial applications, not your commercial car. That comes when the infrastructure comes, when the technology comes. So it's almost like we're focusing on the end technology, like the downstream technology of where hydrogen might be used, but really you'll see this vast application of it used in these other areas.
Right. It's a process. It's a sequence, and we can't do move number 15 when it's actually move number 4. You know what I mean? It's like you're playing a game of chess. It's a complex game of chess, and there's a certain sequence that's associated with how do you get to that end goal. And we're trying to put the the cart before the horse, or is that expression that you're trying to put the cart before the horse, something like that?
Yeah.
But yeah, it was like, hold on a minute. Like, yeah, we're trying to get to the point of hydrogen to power vehicles, but there's many different applications. And if we can get hydrogen to be used and generated in a clean manner for those different applications, and then once there's hydrogen power generating facilities or hydrogen producing facilities, that are there, then we can introduce cars, because it's kind of like a chicken and an egg thing when you're talking about the vehicles thing, where do you get vehicles but there's no hydrogen producers? But if there's no but then if you have hydrogen producers but then no vehicles, then it's kind of like which one comes first? Well, maybe since there's already a demand for hydrogen in different sectors, you have hydrogen being produced for those sectors and then gradually introduce the vehicles after the fact. But I want to go back to the fuel rich and fuel lean nature of hydrogen that you talked about, and that's also could be seen as one of the benefits of it too, is that you have a much wider band that you can play around with, so you can achieve higher degrees of efficiency with regards to, like, if you're just looking at the combustion of hydrogen and
in an engine. Yeah,
exactly.
As an accident, it poses a problem, but when you're trying to blend hydrogen with air to have it explode inside of an engine in a gas turbine, I think it plays an advantage.
Exactly. Because that means that you can operate more efficiently with different air mixtures, so you're maintaining that efficiency at various mixtures of oxygen. Then I want to just go back to what he's talked about the metal embrittlement. And yes, that's an issue, but I mean, there's also the degradation of batteries over time as well, and and this is like the chemical nature of batteries and the oxidation that inevitably happens. There's a limited number of recharges you can do to your batteries. It's not perpetual. And so again, there's pros and cons. There's technological and engineering barriers with any technology. So so again, like, he just seems like the real Debbie Downer, for lack of a better terms. Like, it causes metal embrittlement. Like, really? Like that's what you have, metal embrittlement? It's kind of like how you pointed out, there's a lot of different methods that we can use to overcome that, whether it's using some sort of polymer coating or maybe even carbon fiber, whatever. It's just like, okay, man, so like batteries corrode too. That's an issue you got to deal with as well. It's just like, so one-dimensional.
It's so one-dimensional. Like Elon Musk's doppelganger, Neon Tusk, could have stood up on a stage and made the same arguments that he just pointed out, all the things wrong, all the issues you're going to run into doing electrical energy. We said it already. Maybe we've said it too many times, but it's just like, it's the criticism so one-sided, and in that way, it's like, okay, and surely it's not dumb. Like, absolutely, it's not dumb. That's a bit much, and that's where I go back to my hypothesis that he used it, he got a laugh from it, and now he's sticking with it, even though it may be a thorn in his side. And I don't know if I have a few more clips. I got clips here about vehicles. I got clips about energy storage. We could skip over that and jump right to it being used as a fuel. What are your thoughts?
I think all those are good to talk about. Honestly, I'm down for all of it, and I have some points to talk about for vehicle. So let me just introduce that point, and then maybe we can go into one of the clips. But in terms of the when you look at your electric vehicle versus your fuel cell hydrogen powered vehicle, one of the interesting advantages that you get with your fuel cell vehicle is that even if you're running low on your hydrogen, you still maintain more or less the same power and quality of car performance. Whereas with an electric battery, the lower the battery gets, the more drained it gets, then this starts to impact the quality of the driving experience. It impacts the power of the vehicle. So that is one interesting advantage that I think that hydrogen does pose, that even if you're running low on fuel, you're still going to be getting more or less the exact same performance of your vehicle.
Till it's empty.
Exactly.
Yeah, much like regular cars, gas cars are today. Instead of it slowly, I think with the Tesla, it starts to shut down like superfluous and secondary systems. It's like, okay, we're going to force all the power into just moving the engine, but the heater and the air conditioning is going to turn off. And, it gets, it's much like your cell phone. How often do you see with your cell phone as the battery starts to go, the reliability of what it predicts it's got left in it gets worse. It's like, you should have 3 hours left, and then it dies like 5 minutes later.
Yes.
When battery's got that problem for sure.
Mm-hmm.
Okay, let's get into clip 3 here. This is on vehicles from the. Let me back up. This is Business Insider, independent guy. But it's coming from a business perspective. He's talking about hydrogen cars and the whole Elon Musk thing. So it's perfect for this.
All right, clip number 3.
If you ask anyone what the future of cars looks like, they'll probably tell you it's electric, and that Tesla is at the forefront of the movement. But what if I told you that there's another option that could be just as good or even better than battery electric vehicles? What if you could power cars with the most abundant resource in the universe, with water as the only byproduct?
Lies.
And they're more likely to disrupt the auto industry than battery-powered cars, like Teslas. Hydrogen fuel cells have been a technology of great promise, as well as great skepticism. Elon Musk himself often mocks hydrogen fuel cell technology, going so far as to call them fool cells and mind-bogglingly stupid. But major automakers still see promise. First, let's define the terms. Battery electric vehicles, or BEVs, are the electric vehicles that most of us are familiar with today, like Teslas. They use a battery to store electricity and power the electric motor. A hydrogen fuel cell electric vehicle, or FCEV, like Toyota's Mirai, combines hydrogen with oxygen to produce electricity, which then powers the electric motor that drives the car. Now, when it comes to why people don't buy battery electric vehicles like Teslas, there are 3 main reasons.
3 main reasons. I remember why I clipped it here. What do you think the 3 main reasons are? If you had to guess.
For not buying a battery electric vehicle like Tesla, one would be like for your classic car enthusiast, they want to feel that power. They want to feel the combustion engine roar, which you don't get with the electric power vehicle. I don't know if these are the actual ones that he lists, but
no, I would call that number 4.
Okay,
if I remember correctly, that's number 4. But that's a valid point. That is, there are people that like the feel of driving a gas-powered combustion engine car.
Yeah,
for sure.
So that's one.
Okay.
Another one would be poor performance in cold weather.
Sure.
I think.
Yeah.
Another one would be the distance issue.
Yep.
That there's a limit in terms of the distance you can travel. Another one would be the long refueling time.
Yep.
That's necessary. So those are the 4 that come to my.
Okay, and I think it basically, we'll hear in the next clip, but cost is going to be in there too.
Cost,
but,
yes.
Yeah, if you play that next clip.
Next clip.
Yeah.
Okay.
Take too long to recharge, they have a limited range before they need to be recharged, and they cost a lot more than your comparable gas-powered car. So, how do hydrogen cars stack up in these areas? When it comes to recharging, hydrogen cars have battery electrics beat. At a supercharging station, a Tesla can charge anywhere from 30% to 50% in 15 minutes. But you'll be at the charging station for over an hour for a full charge. Fuel cell vehicles don't require charging at all. The hydrogen tank is refilled at a hydrogen station in less than 5 minutes, just like your typical gas station today. That's because FCEVs don't store electricity like a battery. They create it on demand to power the motor. When it comes to range, hydrogen-powered cars seem to come out on top again. Between the 3 fuel cell vehicles on the road today, they have a range of 312, 360, and 380 miles. Most electric vehicles have a range under 250 miles. While some Tesla models offer a range of more than 300 miles, they often cost more than the average car buyer can afford. Range and refueling times are so important that 78% of automotive executives believe fuel cell vehicles will be the breakthrough for electric mobility. But that's not to say fuel cell vehicles don't have challenges of their own. FCEVs need more competitive pricing. The suggested retail price for the fuel cell vehicles available today is around $60,000, which is about $20,000 more than an entry-level BEV. That's because production size of these vehicles is incredibly low. With only a few thousand or few hundred being made every year, it's nearly impossible for prices to be competitive. But that could soon be changing. Automakers are looking to increase the production of their FCEVs. Toyota, in particular, has increased its production capabilities tenfold to eventually bring down the cost of its Mirai.
That was way too long of a clip. But I wanted to point out is what he points out about the distance and the refueling time, and about like 72% of automakers think that this is like very important for the popularity of hydrogen in the future. I think that's valid. I think that's so valid because the reason they're so expensive right now, let's talk about the cost prohibitive nature. It's just like the electric. There's a whole infrastructure side of things that needs to be developed for it to get there. But let's say we eventually get there, then people don't want to step backwards in terms of what their technology delivers to can deliver to them. So what I'm saying by that is, I don't think some people don't want to go into the electric because it underperforms from the gas combustion, right? So if you can get something closer that exceeds, or is comparable to what the current technology is at the same price market, it becomes way easier for people to get on board. But like both cases, the price comes from a lot of the fact that there's a little infrastructure coming, and like we discussed earlier, it's the cart before before the horse scenario. We're getting ahead of ourselves with the hydrogen. Once you have hydrogen being used all around for power generation, energy storage, that infrastructure gets built. It becomes easier to move that into power stations, and then once those exist, it becomes more appealing for people to buy the car.
Mm-hmm. And as one of the criticisms that Elon Musk pointed out as being the storage and transportation of hydrogen, well, when you do it in such a manner where, kind of like is mentioned in this video, where you have your hydrogen fueling stations, and if it's generated on site, right, which you can do because all you need is electricity to that station, then it's then at that station you have hydrogen generated subsequently, then this kind of avoids the whole issue of transporting hydrogen because it's made on site. You don't have to deliver it like how you would deliver your gasoline to your gasoline
tank,
your gas station, or your gas tank. Rather, you have your hydrogen fueling station, you have electricity that comes to it, you hook it up with an electrolysis machine and an electrolyzer, and then you simply, when you have those moments, and again, if we're moving towards a green, sustainable, quote unquote, power grid, which is what Elon Musk is all about, then we're going to have more renewable energies. Well, when you have those renewable energies and they are generating power that's not being utilized, why not convert it into hydrogen? Okay, now you have hydrogen. Okay, so then you have hydrogen fueling stations that are almost generating free hydrogen in a sense, after your capital costs and all that stuff. But then you have hydrogen on site, and then you have your vehicles that are able to go and refuel as necessary. So you've cut out those issues of storage and transportation because it's on site.
And I wouldn't say you've got rid of them, but you basically presented another option for it, because I foresee, like anything, if you're close enough to a mega producer of hydrogen, like one of these reforming plants, it may make sense economically to run the pipe directly to your fuel station. You don't need to. You just transport underground through a pipe, goes to your fuel station. It might make economic sense sometimes if you're close to some place that does mass storage of it and puts hydrogen into a tank. You'll just ship those off. But like you said, you still have the option of making in like remote areas where it makes more economical sense to not transport hydrogen there, have hydrogen production right on site. You have your renewable energy, you make hydrogen, you compress it on site, guy pulls up in his truck, hydrogen fuel cell powered, and he fills up his tank. You know, it's just, can you say that for gas? Of course you can't. You can't create gas. Gas always comes from the refineries, always requires transportation.
And there's emissions during that transportation.
Right.
And so when you compare hydrogen even to gasoline and that a system that's currently in place, you see benefits as well. So you can't just compare hydrogen to electricity or battery electric cars, because we're still competing with different types of cars here. It's not only battery electric that have taken over the market. We're still competing with combustion engines as well. And how does hydrogen benefit in relation to those? Mm-hmm. So it does present that benefit of on-site fueling. And that's just the point that I really want to hammer home. If you could take away one thing from this podcast, to me, the most important thing is that when we have a power grid that's based off of renewable energies and we're generating surplus power, why not store it in a method that allows for long-term storage, which is better than your battery electric. Battery electric is good for short term. It's not good for your long-term storage. And hydrogen it's not only me that's saying that. There's plenty of academic research that is going down this route. So again, to think of it as a fool's errand, I think is really dismissive and irresponsible.
You're right. It's not just you saying it. You want to hit clip number 6?
Application for hydrogen that has experts excited is the ability to use it for storing renewable energy that would otherwise be wasted.
What's really made hydrogen come on the scene now is the simple fact that we have so much renewable power on the electric grid in places like California and Texas, which we didn't have 15 years ago. But with all this renewable power on the grid, we are now getting substantial curtailments of electricity, which is a market signal that we need storage. And so the reason hydrogen's really caught on right now is people are realizing it's really sort of an ideal way to store renewable power for long periods of time.
Mitsubishi Power, along with fuel storage company Magnum Development, are working on a project in Utah which promises to build a storage facility for 1,000 megawatts of clean power, partly by keeping hydrogen in salt caverns. Scheduled to be operational by 2025, the Advanced Clean Energy Storage Project would be the largest clean energy storage system in the world.
So we're going to build a very large electrolysis system that will be able to convert renewable power into hydrogen, and then we're going to store that hydrogen in that salt dome for long periods of time so that it can be used when the grid needs the electricity instead of when it's produced.
The hydrogen stored in the salt mines will be used by a power plant next door.
The Intermountain Power Project, which is in Delta, Utah, is the last coal-fired power plant that's providing power to the state of California, and it's scheduled to be retired in 2025. Intermountain Power has selected our equipment to repower that power plant with gas turbines. But they've asked us to make these the first heavy-duty gas turbines ever that can provide this power with a mixture of natural gas and hydrogen.
Browning says that initially, the gas turbines will use 30% hydrogen and 70% natural gas. But the goal is to use 100% green hydrogen by 2045.
Phase 1 of our ACES project is going to be capable of 150,000 megawatt hours of energy storage. And 150,000 megawatt hours is enough to fuel 30% of an 840 megawatt power plant. And 840 megawatts is enough power to supply 1/7 of the peak needs of the city of Los Angeles.
Okay, 1/7 of the peak needs doesn't sound like a lot, but
It's not nothing.
It's not nothing. And there's so many interesting concepts that came out of that. So first off, salt domes. I had no idea what these were. So if you're listening and going, salt domes, storing hydrogen salt dome, what does that even mean? Well, you're not alone. Okay, what this means is there are these geological formations underground that are made up of salt, and you can basically, using water to dissolve the salt, hollow out these caverns. Some of them are already kind of hollowed out naturally through water movement and such, but you basically create underground this cave, and once you get the cave big enough and you secure it in all the right places, you can use it to store gas. And so in Utah, they're planning to basically make the largest in the world to store hydrogen gas.
It's great. Love it.
Bananas. Now, we're getting to the point, which is what are energy producers really using hydrogen for right now? What are they? How are we going to take the steps to make hydrogen something we use and on a daily basis and build our grid off of it? So the idea, the way I understand it, is something like this: we already use natural gas. Okay, natural gas, we mine it out of the ground. It's got methane. We've talked about this before. You pump that over to your power station and you run it through a gas turbine. You ignite it in the gas turbine. The explosion causes the, for lack of my understanding of it, something to rotate, and you get your electricity to be, it's formed, right? Now they're saying, okay, so we use natural gas. What if we start to blend in hydrogen? So he was talking about, at the beginning, they're only going to have 30% of their gas, being going into these turbines being hydrogen. The other 70% is going to be natural gas, but slowly increasing that amount of hydrogen. So the problem he runs into is they need to be heavy duty turbines, and you got to build turbines that can handle the combustion of hydrogen, which is something that GE, General Electronics, is looking at doing, and we'll talk about a little bit later. Did you want to go to the second part of that energy storage one, or?
Yeah, sure. So I just wanted to, just comment on what that guy was saying.
Yeah.
With again, just how with the changing of the landscape. Again, we have to always consider how things play within the landscape that we are currently in, and how with the advent of more renewables into the grid, that's what can further justify using hydrogen as a form of storage. And that's one of the main reasons why it's becoming to make more and more sense, because it's about economies of scale and whether or not you can scale these types of technologies. It's not just good enough for them to work in a small reactor in a lab, but can it work? And then does it make sense financially? And if people are willing to spend the money, then that's when technologies become adopted. And right now people are willing to spend the money because people do see climate change as an issue that does require some attention. But even beyond just that, even just like not looking at it from a climate change point of view, because that's so politicized, but just from the point of view of, do you want clean air? Do you want to minimize the amount of tailpipe emissions within cities, where we can maybe centralize them to big, large-scale producers, and then take care of the emissions more locally on site, as opposed to having them distributed throughout the whole city? It's like these types of little nuanced questions that you have to consider.
Exactly, yeah.
So let's go into the next clip.
Today, companies like NextEra Energy, Eos Energy, and even Tesla store excess renewable energy in batteries. But there's a big drawback.
If you're only storing electricity for a short period of time, it's much better to store it in a battery. You can do that at a lower cost, so there's a better efficiency to that storage process. But if you want to store electricity for a long period of time, battery storage gets more and more expensive. You have to build more and more batteries. Whereas with hydrogen, we can store it underground in large salt domes for long periods of time at very low cost.
Okay, that was just a short one, but I thought it's just another good point for the use of this technology. The storage length for hydrogen is much longer than that for batteries. So one thing that came to mind is, let's talk about generators. Right now, in Canada, a lot of industrial buildings, universities, they'll have backup generators in case we get a storm that takes down our power grid, and you need to have the power back on. So you have diesel sitting around in tanks ready to power the generator. Well, an alternative to that now, and is proven, is hydrogen. Hydrogen works in that same way. You can just keep a tank of it around and have it available for power generation. I mean, I don't think it's unreasonable to think it could become possible that even the smaller generators you take camping or you use on the construction site to run any type of electronics, your drills, your heavy, your computer, just lighting. You could foresee that you could buy a canister of compressed hydrogen and fit it into your generator. So I'm just showing how this it can be applied into these different in these different ways.
Yeah, there's definitely different domains of application, whether it's the large-scale power grid or small-scale generators or vehicles. The applications are kind of limitless, and we're just bound by our own imagination and creativity. And I think what that gentleman alluded to is the important factor to consider, that there's long-term storage benefits of storing that power in hydrogen. So in the form of hydrogen versus electric, an electric battery. So I think people kind of get into like these certain ideas and they just know this is the one, this is the answer. They get into their ideological preconceived notions like, okay, this is the one and it's always the one. But you just have to always consider that there's no magic answer, there's no silver bullet, one size fits all solution when it comes to these types of questions and concerns, because there has to be, like, for example, geography is considered. Like, we're talking about salt domes here, and maybe not every location is conducive to having salt domes,
right,
where you can store thousands of kilograms of hydrogen, right? So again, we have to consider what are the things that we have at play that we can use to our advantage. We have to be a bit creative here, and that's why we have to consider that sometimes, okay, maybe it makes sense to use battery storage. Sometimes maybe hydrogen storage is the better alternative when we're looking for more long-term storage applications and things of that nature. So it's just always to consider that, hey, we're not necessarily saying one is better than the other, but we're just kind of trying to maybe point out how there are benefits of one. It's not necessarily conclusive that electric batteries are the way to go for energy storage. And there's a lot of evidence to showcase that in certain scenarios, hydrogen is the better option. Maybe in other scenarios, battery electric is the better option. But hey, let's not just jump the gun and say, no, that's foolish. Why even do that? And just, close the book on that before we even started to read. Let's read at least the first few chapters, man. Like, come on, before you judge the book. Don't judge the book by its cover, as they say.
Yeah, exactly. And we've never said that. This whole podcast has been about not us trying to push one technology as the fix-all. In fact, the idea, if I may sum it up, is we want to look at a whole host of technologies, tailor them to the characteristics and the needs at the individual city level that can work, okay? For the geography, for the country, whatever. We open up the toolbox, we look at what we can use efficiently. We're trying to peel off the political, the ideological barriers that are saying, no, you can't do this or that. Go, okay, can we use these technologies? Are they good? And we also are big proponents of, yeah, we want to see renewables introduced into our grid, but we don't want to see that at the cost of electricity going up crazy astronomical amounts and impacting people's livelihoods by making it just costly to live. Basically, you just go back and listen to any of our episodes. We talk about all these issues here. What I think what we're trying to do specifically on this one is say, listen, nobody's talking about hydrogen, and we talk. That was the thing. That was my whole bit on energy storage. We did a whole podcast on energy storage, and I took 2 or 3, sources, media sources, talking about energy storage, and all of them were talking battery and gravity systems. Nobody brought up hydrogen. Why not? And even that one guy that did the PhD who did that whole paper, he was using data from Europe where they use hydrogen and energy storage through hydrogen, and he just kind of just didn't mention it.
Yeah.
So that can only be political or something, because it's not like we're talking about something that nobody is using. It's a failed technology. No, people are investing. Car companies are investing in it. Lead infrastructure companies are investing in it. In fact, I got a clip here, clip 8, from the CEO of, I believe it's an Italian or a European company that does infrastructure, much like GM, who talking about the evolution of using hydrogen. So he says some really interesting things. Do you wanna click on clip number 8?
No, let's do it.
Talking of various hydrocarbons, it seems that coal's on its way out. That is almost uninvestable for many people nowadays. Oil is finding its own problems as well, but gas is contestable. I spoke to Martin Wetzler about this at Gas Tech in the last few days as well, and they are still fighting the fight for gas. You are still fighting the fight for gas as well, for various products and compressed natural gas and liquefied natural gas, but there are still echelons of people, environmentalists, who just say gas cannot be part of the equation.
I think that's true in the very long term, and I think everyone agrees with that. By 2050, at least in Europe, we have to get gas out. We need new types of gas, so we can have biomethane, we can have low carbon gases, we can have zero carbon gases like hydrogen. But there's still a long way to go to get rid of diesel and coal and replace those with gas is very environmentally friendly, because it's a lot less CO2, and at today's prices it's very convenient from economic
And yet
perspective.
many people, and this is right into your ballpark, don't want to invest in that gas infrastructure in either whether it's the United States or whether it's this part of the world. They're concerned about the low prices as well and getting a return on that investment longer term as well. Is that a realistic concern?
I think it's true that prices right now in many parts of the world are extraordinarily depressed, so no one's really investing right now. But what we need to do is to get gas clean and gas green, and that transition will require hundreds of billions of dollars of new investments. We need some policy nudges, some pushes, some incentives to make it happen. Not huge, we don't need to do all the things we did for solar, but we need some help from policymakers, and that will really unleash a very positive transition.
Will that happen?
Sorry, I finish off in the next clip about that interview. A lot is said there. I mean, okay, let me start here. First, he's alluding to, again, how do we turn around the battleship? It's a slow turn, okay? We have all these different ways of producing electricity. You got to give a reason to phase them out, and one of the things he's saying, okay, so you start investing in gas turbines, and gas turbines can currently be fueled through methane. Slowly you start to blend that up with hydrogen. He's seeing that's a reason to make that change, and the big push arguably is the ideas around climate change to change over here, right? He's saying, okay, we need to start investing in that. It sounded like people aren't interested in investing in that, and he agrees with that, but he's like, okay, we need some help, policy help. Now, policy help is a whole other thing we could talk about, because we've seen it done right, or seen it done wrong. And, we talk about fixing prices and subsidies. And, but he says not, we don't need everything they did for solar. And, solar being what it is, and people saying, oh, it's the cheapest way to create electricity. But it's one of the things where it's like, and, all the things that we've done to make solar what it is now, and what we've needed to create solar what it is now, like we've needed China to manufacture it in a state where they're just getting all their electricity from coal and producing cheap. There's a whole other thing, right? We've talked about this before, but the point is, here's a guy looking at the big picture, talking about gas being the future, talking about it being used in these gas turbines, and talking about some of the hurdles that are in front of him. Any thoughts on that?
Yeah, I think it's just like the whole notion that there is a push away from coal and oil, and I think that's really important that it is done in such a way where it's stepwise, and again, we don't go towards the end, the move number 15 when it's actually move number 4.
Yeah.
Right. And I think that's what that guy's kind of alluding to, that there's long-term solutions and there's short-term solutions, and in the intermediary, natural gas does need to be used as a transition away from coal, and then from there we can use that to transition towards more hydrogen. And I think that there's a lot of opponents to natural gas because, again, they want to get to that final destination as quick as possible.
Yep.
However, I think in a realistic sense, we do need those intermediary steps, because we don't want to go out of sequence, because then it's going to end up costing even more down the line, because something is going to happen that was unforeseen, that is just going to lead us to backtrack and say, wait, we messed this up. We should have actually done it like this when we did it like that. We did move number 15 when it was time to do move number 5. And I think that's really an important point to consider. And I just wanted to touch on real quick about like the advent of more hydrogen vehicles as well. That when we were kind of talking about, when one of the previous clips, I actually wanted to say this, but I just remember this now, where it's talking about different car companies and how they're generating fuel cell vehicles. And he mentioned Toyota, the Mirai. And I just looking at this now, actually, I had found an interesting article that was talking about Toyota and how they had created a hydrogen engine that's based off of just combustion, right? So they already have the fuel cell vehicle, and now they're developing with a higher degree of energy and a higher degree of resources, a combustion vehicle that's based off of hydrogen. So
instead of using a fuel cell, you're sending it into an engine where you just basically ignite
Suck, squeeze, bang, blow, baby. Suck, squeeze, bang, blow.
Wow.
Yeah, so it is to say that there is a lot of movement in this direction. There's some interest, and where you're not only going to have your fuel cell, which is again, you have your hydrogen that's converted into electricity, but rather your hydrogen that's used via your traditional combustion process. So it's kind of like the combustion engine is not beat and defeated, I don't think. And again, when I go back to certain advocates of the combustion engine that just love the feel of the engine, that rumbling, that sensation that you get when you're driving, and I'm personally not one of those people. Like, I'm just whatever, but some people just love that stuff. So if you want to sell to that market, well, you better have something that they're going to enjoy. And what better than to give them something that's going to fulfill all those psychological points? It's going to hit that vibration. It's going to hit that noise. It's going to have that feel. But on top of that, it produces a clean exhaust. I think that's great.
If they can pull that off, that would be incredible. Because something we haven't discussed about the fuel cell is this catalyst, which the best catalyst that we know of so far is using platinum. You have to coat it with platinum. And I read this whole journal article in Johnson and Mattei was the name of the journal, and it's the role of platinum in proton exchange membrane fuel cells, the fuel cell that we described at the beginning of this podcast. But they basically analyzed it and determined that of all known catalysts for hydrogen, platinum is by far the best. Like everything else underperforms, and they basically conclude that here, let me read a little bit from the very conclusion. So the relative cost of a gram of platinum makes the promise of systems using cheaper metals seductive. So they're saying platinum is expensive, it's rare, so it costs a lot. So can we, it's seductive to think, can we make a catalyst a catalyst from another material? They go on, they say, however, alternative systems containing base metals have fundamental limitations such as the lack of activity, poor selectivity, leading to H2O2 formation or catalyst degradation caused by lack of stability under the fuel cell operating conditions, which all must be addressed. So when they talk about lack of activity and selectivity, these are terms described later. I'm not going to go into them here, but these were the criteria which they were judging the performance of the catalyst. And then they say these other catalysts made the formation of H2O2. That's hydrogen peroxide. It looks like water, but it's hydrogen peroxide, and that is that's corrosive in small amounts. Is fatal if you breathe or drink it. So you don't want to be making that as a result. So the final sentence of that conclusion is this. It says, as academia and industry continues to develop both platinum and non-platinum systems, the question for the future is whether the greater lead that the platinum systems have in both utility and economics will reduce or as seems more likely, increase. So they're saying, okay, even if because they talk about in the journal the way that we're currently doing platinum systems, there's still a few tweaks we can do, such as like using less platinum just using it on the very surface of the anode and cathode in our fuel cells. That could basically up its performance, but it's still like a fundamental part of it. So my whole point here is that platinum's expensive. It's kind of one of the limiting factors in these fuel cells. So if they can pull off a combustion version, man, that changes things, I think, a lot in terms of having a mix of possibilities.
Yeah, and we won't go into too much detail on the combustion of hydrogen and the flaws of it, because there are disadvantages, and I'm sure if you Googled it, you'll find a host of people that talk about the disadvantages of using hydrogen for combustion. However, if Toyota, one of the biggest car manufacturers in the world, has just recently announced this was an article that I pulled up just today, but they had written this in just a couple of weeks ago, April 22nd, 2021. So this is a very recent development. So they are looking at this very closely right now. I'm only curious to see what's gonna come out of it, because they already have decades of research on hydrogen by virtue of working on the Toyota Mirai and the Mirai 2.0, and I'm very curious to see how that's just going to develop throughout the years.
Now Toyota, that's is that Japan or where's right?
Japanese.
Okay, interesting. Yeah. Let's play that next clip, because I think he talks about different places in the world that are really pushing the hydrogen, and that's one of them.
Clip number 10?
Clip number 10. Yes, yeah.
In geographical areas such as Europe, or will it be areas such as China and such as India? Because I know that you're looking at both of those areas in really meaningful ways.
It's very interesting you ask. I think the race is on. I think Korea Japan, China, India are really pushing the hydrogen agenda forward. Europe is doing so as well. I think Europe will and can keep the lead because it has come out with a very explicit hydrogen strategy, which is very bold. And I think technology and energy will blend together and find a way to give us a solution.
And we've talked about hydrogen in Davos before, and I know that it is, if there was a man who's passionate about it, it's you, Marco, as well. But there is a public opinion problem with hydrogen, isn't there? And I know that's one of your key challenges and something you continue to present on. But you have solutions for that, do you?
Yeah, I think consumers have to come at the end. I think we need to first get into lorries, into trains, into factories. Cars will come. Hydrogen will become much cheaper, will become competitive with fossil fuels, we think, in 5 to 10 years. But we need to leave cars for last. The problem with hydrogen, it started with cars, but cars have their own challenge in consumers and infrastructure and availability of cars. We'll get there, but we need to start with a heavy industry. We need to start with all those, what we call hard to abate sectors, where it's really hard to get electrons in. It's really hard to have a steel plant running on electricity or a truck running on batteries. That's where hydrogen starts. And then eventually, when we get more comfortable with it, when it gets cheaper, it gets to consumers.
Cart before the horse. You know, he's making that exact point that we made earlier. And I laughed when they said I talked about this in Davos. Davos, a bunch of elite people flying on in private jets to talk about climate change. Davos. But yeah, I mean, he says right there in that clip, look at the countries he's listing that are pushing it. Japan was there, China, India, and Europe. Nowhere was there mentioned Canada, the U.S. You know, the earlier clips we heard were coming from, you know, California and stuff like that. But you can see the difference across the pond in terms of the
urgency.
The urgency or just the acceptability of hydrogen, into their societies, into their, you know, energy production.
Mm-hmm. And I think he made a good point about how there has to be a transition, and at first it's more heavier industries that need to incorporate hydrogen. And to that end, one of the articles that I pulled up was in relation to the hydrogen buses, the hydrogen bus fleet that was purchased and used in Vancouver for the 2010 Vancouver Olympics. So it was kind of like done as a test proof of concept type of thing. And the timing was great because it was the Vancouver Olympics, so all eyes were on Canada, on Vancouver. And, what better thing to do than show off the new technologies that you have running within your cities. So they had purchased a fleet of vehicles, of buses that were powered on hydrogen. And this came under criticism several years later because they had to cancel the program and they no longer used the hydrogen powered buses. However, I think I found this article and it kind of like phrased it in a different light, and it kind of addressed some of the main goals of the project, and that was that it was not meant to necessarily be a project that kept on going, but rather it was meant to be a 5-year demonstration to see whether hydrogen buses could handle daily service year round. And to that end, the buses ran from 2010 to 2014. They were used for up to 22 hours a day. So that's quite a bit in a day, for more than 4 million kilometers of daily service in temperatures as low as minus 20 degrees Celsius. So that to say that the premise behind using these buses was a first time. Keep in mind that at this point in time, nowhere else had done it. So this was literally the first place where buses had been rolled out and used that were powered based off of hydrogen. And as a proof of concept, like, hey, can we run this? Can we service these buses on a daily basis, on a monthly, on a yearly basis? And they were able to do so and have buy-in from the community, which is also kind of important. What this gentleman touched on as well was getting the acceptability from the community, getting the acceptability from society that, hey, this is something that really jives with our values. And those were all checks that they were able to tick off with this project. So and after this has led to now a boom of hydrogen-powered buses that has taken place, and now there's literally thousands of hydrogen buses globally. Unfortunately, none of them in Canada or US, I don't think, as well. But globally, this has led to thousands of buses that are powered on hydrogen to be in operation, to be in circulation. So it was a proof of concept to show that, hey, you can run hydrogen-powered vehicles for 4 years. You can have your maintenance, your serviceability, all that stuff, and you're good to go. And I think that was just kind of like an interesting proof of concept to show that this is doable. It's going to cost more. At the time, the buses were $2.1 million for each, whereas a similar diesel-powered bus was about $600,000. So there are those differences. However, from what I was reading, though, the cost of the bus has actually gone down at now,
of course,
from 2.1 million to maybe 1.2 million per bus, and soon to be around 1 million as well. So the price of the buses are going down, and to be like more comparable with a diesel powered bus. So all that to say that you might have to pay a bit more, but it's getting to that point where maybe people will be willing to pay more. Maybe they will pay more, just that extra little bit to cover the initial capital cost, but then long term there might be then you have to look at the payback period and all that stuff, not to get into the economics of things, but
yeah, maybe they don't pay more. Maybe they even won't have to pay more. Mm-hmm. Okay, so let's talk about this, because the way it was presented, I know how it was presented. It was like, Vancouver is on the world stage hosting the Olympics, and we all know the bullshit that goes on with hosting the Olympics. You move your homeless away, you clean up your city, da-da-da-da. There's things people do to make themselves look good that people don't like, and I get that. So the idea here was that they had the hydrogen buses, and then people left, the world's eyes left them, and they didn't keep those hydrogen buses. But as what I'm hearing you say from this article, that was never the intent. And what they actually were doing was, doing a pilot scale. And we talk about the scalability and testing out a technology's ability to scale. These are the type of things you have to do. I had an interesting experience when I worked for a local municipality. They were trying to expand their water treatment system, their wastewater treatment system, because the community was growing, and they knew they were going to have more wastewater they had to treat. And so instead of pouring a bunch of money into just making all their tanks bigger, they tried this novel technology, which uses magnetite, which is a mineral that they would introduce as a powder into their tanks, and it was supposed to latch on to some of the solids and help it settle out quicker. And then as those solids were scraped off the bottom, they would use a magnet to collect all the powder back, and they would go over and over. So it's very kind of unique, novel solution to it. They tried it out, okay, for a whole summer. They got the results back, and you know what? They didn't use it. However, okay, this technology is not dead. This technology is continuing to get better, and its ability for communities who are often, like rural ones, are very conservative. They're more likely to stick with the status quo or proven technologies. They had the wisdom to try out something new. That company gets new data on how it can actually work in a community. It goes back to the drawing board and maybe fixes some of the issues that it was having. And the issue, I believe, was it was clogging up the filter downstream with the small amounts of magnetite that was getting through. So, when we talk about emerging technologies, you have to have a platform or a willing audience, a willing government to allow you to try it at some scale, and then you take the lessons learned from there. So now with people using, Vancouver using the buses for 5 years, they see all the problems with it. Now, but as Europe and Asia starts to develop hydrogen into their infrastructure, and that surely will leak over to Canada, because everything follows eventually, and works both ways. But we're going to be able to come back to the idea of having hydrogen buses again. at some point, and we're going to have, all the benefits of knowing what we need to know about them from these attempts that we've tried earlier. And you have to do these things, especially in Canada, when you have, like, obviously Vancouver is not as cold as Alberta or Ottawa, and you don't want to buy things like a light rail train that doesn't work in the winter. But
who would do that?
Who would do that? But you want, there's steps to this, and you got to prove that works in the right climate, and that's one of the things they did. So, I think that's a really good point, that you can't just dismiss this from that one perspective I presented earlier, that like, oh, so hypocritical. They had it while the world was looking, and then tossed it as soon as they looked away, type thing.
Yeah, exactly. And to add to that, when you do have these different technologies that are emerging, again, like, kind of like what that gentleman was saying, where we have to start big, then go small. Well, one other area where hydrogen powered vehicles would really excel are also in air travel, which a lot of people look at and say, hey, we have all these airplanes that are traveling all over the world. Travel tourism has exploded in the last decade or so. People want to travel all over the place, and that is a huge source of pollution. Well, your battery power method of transportation doesn't really tackle airplanes whatsoever. Enter hydrogen and Airbus. They're a little company you might be familiar with, Airbus, but
Airbus, never heard of them.
Yeah, but they make some airplanes that are used around the world, and they actually had another article that I found dated November 26, 2020, looking at a hydrogen combustion engine for their airplanes. So we have Airbus, one of the biggest airplane producers in the world, that are also looking at using hydrogen as a combustion methodology for their airplanes, which goes back to reducing the emissions associated with air travel, which is quite large, because again, traveling has just boomed so much in the last few years. So I just found that was pretty interesting, that we have such huge companies like Toyota, like Airbus, and that they're looking at the solutions at a large scale as well. So we have buses, we have airplanes that could potentially be running on hydrogen. And again, when we're looking at battery electric vehicles, they are nowhere to be seen when it comes to larger applications, when it comes to your airplanes, your big trucks. So one area of application where hydrogen does excel in relation to electric batteries is these bigger airplanes, trucks, so on and so forth.
I think one of the major hurdles is just simply weight. You just can't, your batteries get way too heavy to power aircrafts of any substantial size. Yeah, that's a big one. That could be a game changer for air travel if they can work that out.
And it had this really interesting quote that I just want to put out there, which just kind of like really, just to put things into perspective. When the world's first internal combustion engine was revved up, it was hydrogen gas, not gasoline or diesel, that burned as it's fueled. The year was 1804, over 200 years ago. After successfully designing several steam-powered carriages, Franco-Swiss inventor Isaac de Rivaz set his sights on using an explosive charge instead of steam inside a stationary engine to power a pump. His first experiments focused on creating an explosion within the engine cylinder to drive the piston out. At that time, he used a mixture of hydrogen and oxygen gas to ignite this explosion, and it worked. By 1807, de Rivaz's experimental prototype engine was being used to propel a carriage a short distance, thereby garnering the distinction as the world's first vehicle driven by an internal combustion engine. So, man, it's crazy. We're looking at like over 200 years of experience with this, but hopefully, I don't know.
Yeah. Because you hear that, you go, oh, like
1804.
1804. Is it has it not taken off because we've run into a hurdle that's insurmountable with terms of technology, or is it just hasn't been looked at with enough interest to get us to the point where this is commercially viable? That's the way I look at that. You know.
Yeah.
But Yeah. Okay. Well, I have an end of episode clip. I like to throw something a little different at the very end, just food for thought. If you're good with wrapping it up, we could hit clip number 12 there. And before I actually, so this is Russell Brand actually talking about
comedian.
Yeah, a comedian, okay. But now a movie actor. He had fought a battle with drug addiction. Now he's quite active podcaster, and he tackles a lot of different topics, including climate change, big tech, a lot of stuff. And he's getting a lot of interesting guests on. But this was just taken from one of his shorter bits commenting on Elon Musk's recent talk about merging people with what's his Mindlink, Neuralink. Okay. But although it's related to Neuralink, I think what he has to say is an interesting point that applies to some of the things we talk about. So go ahead and hit number 12 there.
Let's do it.
A good purpose, which is to cure important diseases, and ultimately to help secure humanity's future as a civilization relative to AI.
Again, I suppose the agenda is being set by people that are in a particular position. I'm not trying to make an enemy of Elon Musk. I met Elon Musk once. He's clearly, unquestionably, a brilliant person. Brilliant person, though, operating within an economic framework. Also, might I contest that his genius is within a particular discipline, and we have this tendency latterly to think that there is a cross-pollination of genius. Oh, this guy's a genius in tech, let's have him organise society. No, this person's a genius in tech, let's have him stick with tech and we'll handle society. In fact, no individual should be charged with such a potent and potentially dangerous endeavour. This is something that we're learning now can only be undertaken collectively. We are so diverse, we are so different. There's nothing wrong with any of our expressions of who we are and how we acculturate, acclimatise, express ourselves, as long as it doesn't hurt other people or the planet. Now, let's, where possible, decentralise and organise our personal realities and our collective realities along lines that are mutually respectful, beneficial, and enjoy the glory of life, the beauty of life, the tragedy of life, its transience, the irrefutable fact of death, the irrefutable fact of pain. Let's use science and technology to improve our experience here within limitations and without the constant agenda of the pursuit of profit. As long as the strata within which these ideas are forced to exist is ultimately a financial and economic one, there will be problems.
All right, I know that was a lot in there, not all related to what we've been discussing, but there's lots to think about in there. But one of the things he says, I'm not trying to make an enemy of Elon Musk, and I'm not trying to make an enemy of Elon Musk either. But and like he very much says, he's a very smart guy who's pursuing some big problems, and he's doing his darnest to work on these problems, and but he's just one man, and he is just one man with one idea about what our future holds. So he might be saying hydrogen's dumb, and that's his opinion. He's entitled to it. He's doing great work in other areas and maybe questionable work in others. But whatever your feelings on it, I think Russell Brand's making the point. Experts are good, and we need them, but they shouldn't be in charge of everything, especially things that go beyond their expertise, such as running societies. And I would say even just maybe specialization beyond what you're specifically working in. If he's working on electricity, maybe he shouldn't be the guy commenting how dumb hydrogen is. I think the point that Russell makes is that a diversity of ideas around this, there's a strength to that. There's a corrective action that happens when you have more diverse ideas. There's more balance. There's less risk in terms of if one goes down, you lose everything because you have this diversity. Russell Brand he's speaking to other things about politics and other things in this, but not to go down that road, but just thinking of it more from our perspective on this podcast about looking at all these different technologies and trying to accumulate them and fit them in where they deserve to be used is a point about diversity and its importance. That's what I got from that clip there.
Yeah, no, I think that's a really important point, that you know what, one person might say something, they might be really smart in their field, and we should maybe consider what they have to say about this other field, but we just have to consider that they have limits to their genius, they have limits to their intelligence, whether they might be really true and really correct in one thing, but they might miss the mark in another discipline. So we have to take it with a grain of salt, understand the limitations of what people are saying, and that it is truly a diversity of ideas, and kind of like goes back to like what I was saying, that there is no one solution, there is no silver bullet when it comes to what is the energy system mechanism that will benefit a particular city. Well, you have to look at the climate of the city, you have to look at the geographies, you have to look at the accessibility to different technologies, and you have to consider all these different variables, and then consider, okay, maybe we need more batteries, maybe we need more hydrogen, maybe we need more methane, natural gas, based on these factors, and then throw in some renewables, this and that. And we just have to just have that in mind, that there is no one size fits all solution when we come to such complex scenarios, such as how do we power a huge grid of electricity. Like, these are complex issues that no one person can truly solve, I think. So
for sure,
I think that was a good way to end the podcast. That was hydrogen. We talked a lot. A lot about hydrogen vehicles, hydrogen storage, large scale applications of hydrogen. I feel like this is going to be a subject that we maybe touch on later episodes as well, just because there's so much to cover. But that was kind of like a cursory look. Hydrogen powered vehicles, they're on the rise. Combustion engine using hydrogen, that's on the rise. Large scale application with airplanes, buses, that's on the rise. And I think more importantly, though, the societal hunger or thirst for it is also on the rise, and people are looking for solutions that are more sustainable, more renewable. And we can get into discussions of what those two mean, but we'll just leave it at that. Maybe that'll be next episode, whatever.
Oh yeah.
But so that was the hydrogen episode. And yeah, if you guys like that, take a minute to give us a good review on your Apple Podcasts, leave us a comment on YouTube, and join our mailing list on our website, firstprinciplespodcast.com. And until then, we are signing off. This was Trees.
And this is Elliot. And I want to say something too. We are in the early stages of developing this podcast, but we're seeing the downloads. We're seeing that people are listening, and I want to say thank you. I mean, it means a lot to us that we aren't just speaking into the void. People are taking their time to listen to what we have to say, and we want to hear from you. Eventually, we're going to set up a platform where we can communicate a bit better with our listeners. Just please be patient. We're on our way there, but thank you. Thank you for listening.
Thank you very much.
Peace.
And we'll catch you guys later. Peace.